All right, so let's actually go ahead and do this kind of crazy multiplication with this list manipulation that we just got done kind of showcasing. So I'm still going to play with the exact same polynomials f and g just because I want to make sure that it all works out. Since we've kind of done it old school, we know what it's going to emerge as. So now we want to rerun the game with this new formula to make sure it's all super tight. So the first thing we want to do is actually convert these polynomials f and g into their respective lists. So again, a0 through a4, the a0 is the constant term all the way up to the a4, which is coming from that degree 4 term. And then same thing for the b's. So they're kind of a flip from how we normally like to write them. So really we should be writing polynomials like this in all of these examples. So sometimes it's also nice to view the leading term out in front. So just kind of be aware as to how we're actually viewing them. But when we convert them into lists, we usually like to think about the 0 term, then connecting to the constant term, and then increase it up from there. So what we saw is that when we multiplied this f with this g, we actually ended up emerging with this polynomial. So we have coefficients of 6, 4, 8, 5, and 7. So what that tells me is that in this crazier multiplication, we should get those little ci's to evaluate to a c0 being 6, c1 being 4, all the way up to c4 being a 7. So somehow we need an operation that's going to take those two and draw it with a proper star, and that those two lists are going to then star into becoming that list. So it's polynomial multiplication via list structure manipulation. So let's go through a few of those just to kind of see how this game is then going to be played. So the first one is going to be the C naught term. So here we're going to have to take those entries from F and G such that the AI and BJs are going to be combined in this clever enough way such that the I's and the J's are going to add up to a 0. The way that I always write these things out is by basically identifying the 5 little A's, so A0 up through A4, and then you play this game of looking for their corresponding B friend. So if A is 0, the way that you can get 0 plus something to add up to a 0 mod 5 is then going to be with the B0. Likewise, if the I value is 1, then you have to take the J value to be 4 to give you a 5, which reduces down into a 0. Likewise, 2 and 3, 3 and 2, 4 and 1. So that is how that sum expands out. And that's kind of an easy bookkeeping way of doing it, is that you write out all of your A values and then you find the corresponding B, which is kind of how this is actually initially viewed, is that you don't necessarily view it as I's and J's. It's like an I, and then the J is K minus I, which is giving me for sure that I and K minus I adds up to K. So that's what's going on there. So if I pull those things, so if I take the corresponding A and B values, so again, remember what they are from there, I'm actually going to see that it combines down into the little 6, which is what it's supposed to be. So hooray. And then in the notes, I actually push this all the way through. So if you wanted to compute what C1 happened to be, so you're going to again compute the AI, BJs such that the I and the J add up to a 1. So you identify just the A's right from the get-go, so that same structural component, and then find the corresponding B value. So if we have a 0 for I, the J has to be a 1. Flip them around. 2 and 4 add up to 5. 2 and 4 add up to 6, which then reduces down into a 1 mod 5. Same with 3 and 3, and then 4 and 2 as well. So you combine those things, it emerges as the C1, which is a 4, which again is hopefully correct. And then if you wanted to do, let's say, the C2 value, so again, you're going to find all the I and J values that add up to 2. So you have the A's, again, printed out from the get-go, and then finding their corresponding friends, so the indices add up to 2. So 0 and 2, 1 and 1, 2 and 0. And then you have to go the elevated version. So 3 and 4 makes 7. 7 reduced mod 5 is a 2. Same thing with the 4 and the 3. So I have all of those kind of sketched out so you can kind of play along to make sure it all works out tidily. And then you go back to saying like, okay, that's sweet. That's exactly what this star operation should and did in fact kick out. So let's switch this over to the Sage world and make sure I can actually find it again, as I kind of struggled last time. So here we're going to have a couple new functions that we're then going to build, and the same kind of notational convention that I did before. So star R is going to have this star construction without the reduction of the coefficients. You can obviously easily do all of this with reducing modulo of prime. So we're going to have star R and then star RP. We'll cruise through the code for this one and then realize that when you update the CKs, when you're computing those, you just do that arithmetic modulo the prime p. So there's really no difference as to what's going on there. So the same kind of boilerplate from the get-go, we're going to identify A and B are going to be coming from your function that you fed into this thing. We're then going to store them as a list. So hooray, we've done all that. And then we're going to begin building up my C. So I'm going to start off by zeroing it all out. And then we're just going to have this big old nested for loop that's going to run through various i's and j's. It's going to see if I and j add up to a k. If the i's and j's add up to a k, then we're going to re-update whatever the ck value happens to be. So it's not necessarily a carbon copy version of what we just did in the example, in that here I'm going to go through all, 25 versions of i's and j's, and then just compute what I plus j happens to be, and then it's going to kind of parse them out as we go. So here it's going to be like 0, 0, and then it's going to say, okay, change C0. And then it's going to be 0, 1, so change C1. And then it's going to be 0, 2, so change C2. And then it's going to back substitute as we go. So it's a kind of a quick and dirty way just to store this as a couple nested for loops. As I mentioned, there are faster ways of doing this, though it's just going to be kind of an initial version that's going to be pretty good for what we have early on. And then when we actually get into some of the kind of weeds of this, we can kind of cycle back to be like, okay, how can we speed this up? What can we do possibly differently? So that's really the main argument is how you'd want to do this. You have two little lists and then recreate the C's. Because we're still viewing these things as polynomials, I'm going to then recreate it back as a polynomial. So it's that unfortunate bit of it ate a polynomial, it turned that into a list, it did list manipulation, and then it's going to rebrand it back as a polynomial at the end. So it's going to return that back to the user as actually having x's in there. Carbon copy the code from before, except for I did one extra thing, in that I put in a reduction modulo p and created a new function called star rp. So we officially could have maybe done that as one and just separated into two little bins, but I liked the consistency of having subscript r or sub r for then no reduction mod p, and then rp if we did do that reduction. So it's a pretty fun little world that you can see that it's pretty easy to actually implement. So if I go back to my little notes, you can see that you're going to eat two lists, change it, pick out another list. We view it actually as polynomial multiplication because it's kind of the nice way to set the stage here, though really it's just list manipulation, and it's just recreating some of these fun little sums to see all of that. The last little bit before we kind of go back into the world of inverses is just a little formal statement about this idea of lifts. So we chatted about this before, is that if you have certain numbers that are coming into play, you can actually begin this process of splitting them up and seeing